दोस्तों जय हिंद जय भारत नमस्कार. In last session number 9 we discussed about the Faraday's law. We discussed a Faraday's invention rather than law, how the force converted into magnetic field and magnetic field converted into electric field. An electric field is nothing but a transfer of charge. Once the source generates the electric field is universe in that particular sphere. At any point it is constant, at any point it is same. Answer is no. I will keep the same spherical, and I will divide it into different segment. Keep the source charge in the center. Once you keep the source charge in the center, it generates the electric field. Now I will go some faster, and then electric field will be generated. You can see the electric field is been generated in all the segment, in all the directions superbly. Once the electric field is been generated, what supposed to be, it is supposed to be a distance r. Now I will try to measure the electric field at a further distance away from the Q. This is the one electric field. But if we want to understood the magnitude of the electric field further away from the source charge, now I will keep this blue lines electric field. By seeing this picture, you can see the magnetic field generated by the source charge with increment in the distance becomes weaker and weaker. It becomes in a less magnitude. That means the the source charge generate a strong magnetic field near, but if you increase the distance, please listen carefully, if you increase the distance from the source charge, the field becomes weakened and it decrease with the square of the distance. Please listen carefully. The magnitude of the electric field now decrease with the square of the distance. It is not a linear but square of the distance. Now further I have increased this particular distance. You can see here, if you increase the distance further, it becomes a less and less strong. That becomes a weaken and weaken, and ultimately now you can see at once you go away, it becomes a less stronger. Ultimately we declared a weak electric field. It it is decrease with a square of the distance. That is the beauty of the electric field. Nearer is a highly density. That means you can see here the arrow indicates the center, red arrow strong, blue is medium, and the yellow one is the weakest electric field. And if you describe the electric field in terms of density, the nearer area is called high density electric field. The If you go away, it becomes a less density, and if you go further away, it becomes extremely less density. So you can define electric field: nearer to the charge it's strong, go away it decrease with the square of the distance, medium, further you go away it becomes a square, less stronger, again decrease with square of the distance, center highly dense, medium, middle, less density, and go further away it extremely less density. How can we prove this? Let me take a three-dimensional. I have a test charge. If I want to I want to prove that it is a square of the distance, it decrease with the square of the distance. How can I prove? Let me take one practical. This is a source charge. It generates the electric field. Now we try to understood in a three-dimensional way. Now you can see it generates the electric field. Red color lines arrow are electric field. Now what's supposed to be a field nearer to the source? You can see here this is the electric field. Now if I keep two square cut area, I will keep this black one square cut area nearer to the source. You can see maximum lines are passing through that particular square. But if I increase the distance, this is the second square, blue color square, distance has been increased, the lines passing are very less. That means the object R and object S. The distance is many lines are crossing to the area R and very few are crossing to area S. That means once it cuts the many lines, that means it's a strong magnetic field. Area S has very less lines, that is indicates a weak magnetic field. Now let me try to explain with some distance. This is the distance R1 and that is the distance R2. Now if I see with a three-dimensional view, if I see with a three-dimensional view, you can see here I have kept one R1 and at a distance R1 and R2. If I see it from the three-dimensional view, the number of lines are passing is same. Students, please listen carefully. If I will not apply a three-dimensional way, first vision is you can see many lines are passing through square R1 and few lines are passing through square S. But if you see from the three-dimensional view, जो मैंने the blue color circle is a three-dimensional view. Maximum lines are passing through R1 and R2 are same. The number of lines cutting through area are almost same. The difference is the distance R1 and R2. That means you can see the number of line cutting through area R1 is nothing but re, uh, reverse of square of the R1 into area. In this particular case, the area is same. Delta omega is the area. The area is same. The number of line cutting through the area R1, what we have mentioned with a blue color circle, is nothing but number of lines divided by the square of the distance into area. And for the distance R2, the number of lines cutting is nothing but number of line n divided by the square of the distance R2 into area. But in this particular case, number of lines are passing are same and area is also almost same. That means if you nullify these two, this particular strength of the field is clearly indicates it is inversely proportional to the square of the distance. The lines are same from the source. The lines generated from the source charge is same. In the last slide we have seen that the lines are same. They are going from source to the extreme end, but with the increment of the distance, the field becomes poor and weaker, and it is nothing but a square inversely proportional to the square of the distance. And that is the beauty of the electrical field. We define the electric field in a three-dimensional way. Once you go away from the source, R1, R2, R3, R4, it decreases the field strength by inversely proportional to the square of the distance. This is an explanation. We will continue the same interesting discussion in topic number 11. Thank you. Dhanyavad.